Hello, Honors Algebra 2, and welcome to Lesson 7.1 on solving quadratics by a method known as completing the square. Okay, so that's our essential question. How do you solve quadratics by this process, completing the square? There's different ways to do it. For the most part, though, this is a pretty nifty way, and it does work for quadratics, which are things raised to the second power. We're going to look at a few different methods here. There's going to be a key little jingle for this. Okay, and the key is going to be that we're going to be taking b over 2a and squaring it. Okay, more on that in a bit. Remember, however, quadratics are in the form ax squared plus bx plus c, and that is our general quadratic form. Standard form right there. Okay, so solve each by completing the square. So I will be specific as to what method to use. These types here, so we got a quadratic, completing the square. The first step is going to be interesting. The first thing, so normally we're going to solve setting equal to 0, but in this case we're actually going to add the c value over first. So we're going to add 20 over and see what happens here. So we have x squared plus 8x plus, I'm going to leave a blank right here, okay, plus I don't know just yet, IDK, equals 20. Okay, now in mathematics, whatever we do to one side, we can do to the other. So we're actually going to be adding that same thing, plus an I don't know value, IDK, to the other side. Now, that IDK value is going to be this b over 2a squared. And I'll show you, and you'll see what happens and why this ends up helping us. So b over 2a squared. Well, our b value is 8. Our a value for right now is 1, which is nice. So the IDK, I don't know, is 8 over 2 times 1, and we're squaring it, which is, so 8 over 2 is 4, and we're going to square that is 16. So we're going to add 16 to each side. You're like, Mr. Dvorsky, why in the world would we do that? Well, here is the little trick. So it's called completing the square because what we now have on this left-hand side is a perfect square trinomial. It's a perfect square trinomial. If you remember about perfect square trinomials, if we were to factor this, it's the same thing as x plus 4, okay? And this side we'll just add together to make 36. And what we can think of this is x plus 4 squared. So we've completed the square. Now, why is this helpful? To solve this now, so now we can solve, you can just take the square root of each side. So square root. When you do that, that means we have x plus 4 is equal to, don't forget plus or minus, the square root of 36. So essentially we have x plus 4 equals plus or minus 6. Here's a little interesting snippet then. So really we have two separate solutions. We have x plus 4 is equal to negative 6, or x plus 4 equals positive 6, because it's plus or minus, which means we have the solutions x equals negative 10, or x equals 2. Okay, in this case they both work. It is a good idea to check for extraneous, but for these ones I'll give you the benefit of the doubt. They both work out. I know that was a lot to soak in, okay, but just gonna follow this process, completing the square, and you're basically doing b over 2a squaring it, and we'll see some other examples as to how to do that. So IDK and all that. So let's do another one here, number 2. So now we don't have 0 on the other side. That's okay, because we're just going to move this 81 over anyway. So first step, we're going to isolate this C value. We're just going to add 81 to each side. Okay, 6 plus 81 is the same thing as 87 equals m squared plus 6m. I'm going to add in that IDK value. I don't know. Well, what is that I don't know value? Well, that is b over 2a squared. So 6 over 2 times 1 squared. Well, 6 over 2 is 3. Squaring it means I'm going to add 9 to each side. Okay, 87 plus 9 is the same thing as 96. Yes. Yep. M squared plus 6m plus 9. If you don't know off the top of your head, that is the perfect square trinomial, which would be m plus 3 squared. If you need to factor it out, that's m plus 3, m plus 3. From this step then, once you have this square, you can just square root each side. So m plus 3 is equal to plus or minus root of 96. It is a good idea. We're going to want to break this up. This is why we're doing this after your square root stuff. So perfect squares that go into 96. So 96 divided by 16. Oh, that one works. So it's the same thing as 16 times 6 plus or minus. So we have plus or minus 4 roots of 6 is equal to m plus 3. And here's a little different way to write irrational answers. So this means that m is equal to negative 3 plus or minus 4 roots of 6. This is your formal answer. In number 1, since they weren't irrational, it came out to be nice numbers. If they're irrational like this one here, you can just leave it like this funky answer, negative 3 plus or minus 4 roots of 6. Why so many colors, Mr. D? I don't know. Okay? So you can leave it irrational like that there. Okay? So it's kind of fun. Completing the square, break it up, solve that. Fun, right? Fun. Yay. Okay? Let's see some other examples. Number 3 here. Okay, in this particular example, now we have a, but it's 7, not 1. Well, we want it to end up being 1. So you could start out a few different ways, but first we'll just subtract 2 from each side. So 7v squared minus 14v equals negative 2. Now, in order to fix this a, let's just divide everything by 7. So we will get a fraction, but that's okay. V squared minus 2v equals negative 2/7. Once that a value is 1, okay, so once this is 1 here, then we can start the completing the square process. So we know we're going to add something to the left, add something to the right. What that something is b over 2a squared. Okay, so b is negative 2 all over 2, squaring it. That means we have 1. We're going to add 1 to each side. Now just be careful. This side, when you make it a perfect square, it's minus 2. So it's v minus 1 squared. Okay? If you need to think of the factors, they'd both have to be negative 1 to work that way. Now on the right side, you can certainly add, I would like you to leave it as a fraction. Negative 2/7 plus 1. Comes out to be 5/7. Okay. From here, you can square root each side. Boop, 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 boop. So we have v minus 1 is equal to plus or minus the square root of 5/7. We're going to have to fix this up a little bit because we don't like square roots in the denominator. But let's just look at essentially what we have here. So if we add 1 to each side, that means v is equal to 1 plus or minus, it goes before the plus or minus, square root of 5/7. Now the thing about this is we don't like the fact that we have a fraction in a radical. So think of it as 1 plus or minus square root of 5 over square root of 7. We can end up multiplying the top and the bottom by square root of 7 over square root of 7, meaning we have 1 plus or minus square root of 35 all over 7. Okay, so that is an acceptable answer. Don't want to have that square root in the denominator. Okay, moving on, example 4. So this time we have a little more to do as well. We can certainly, if you notice this 5 here, and hey, they all divide by 5, you can certainly divide everything by 5 first. Okay, so p squared plus 4p minus 3 equals 2. From here then, so we're going to work on completing the square. Add that 3 over. So p squared plus 4p plus, I don't know, equals 5 plus, I don't know. What goes in there? That's our b over 2a squared. So 4 over 2 squared is just another, 4 over 2 is 2, so it's actually just going to be 4. Okay, so this is going to transform into p plus 2 squared. Remember, factoring it out if you need to. That's a p plus 2 and a p plus 2 equals 9. And from here we can square root each side. So p plus 2 is equal to plus or minus square root of 9. Here's another example where it comes out to be nice. So p plus 2 is equal to plus or minus 3. From here, p is equal to negative 2 plus or minus 3, which means I have two possible solutions. P is equal to negative 2 plus 3, or negative 2 minus 3, which means we have 1, or p is equal to negative 5. Okay, so if it can come out to be a whole number or an integer, please take that extra step and do that if you get a perfect square that you can take the square root of. Okay, last example to kind of show you guys what's going on here. So nothing really crazy tricky. So we can just start. We already have 1. We'll just start moving that 72 over. R squared plus 2r equals negative 72. Okay, I know I'm going to have an I don't know value plus an I don't know equals negative 72 plus an I don't know. And what that value is, hey, b over 2a squared. Okay, it really is just b over 2 squared. You don't need to worry about the a. But what that comes out to be then is 2 over 2, so 1 and 1, meaning we have r plus 1 squared. That's what that side becomes, equals negative 71. Let's see here. So we're going to take square root. We can square root each side. R plus 1 is equal to plus or minus, oh no, the square root of a negative 71. Here's where everything comes into play. Square root of a negative is our buddy I. So plus or minus I roots of 71. No perfect squares go into that, so we'll just leave it like that. And the final part is to subtract 1, plus or minus I roots 71. You can leave it like that. That is an imaginary solution. Ooh, fancy schmancy. Okay, so that's the main idea. Now there are some practice problems that you are required to try, so definitely try these, especially with time coming short. All very similar. Just remember, b over 2 squared, okay, or b over 2a, just really b over 2. Make sure a is equal to 1, okay. Try those out, check your answers to those, and I'll be looking to see if you completed those as well tomorrow in class. So completing the square. Nice job, guys. Good job.